Hello everyone, welcome to day 4 by Tech with Machines. I welcome you back to my channel Tech with Machines, and today's topic is Python lists. We are going to go through the introduction of Python lists. We're also going to talk about the operations which apply to a list, as well as two main concepts called indexing and slicing and list comprehensions. Third and fourth point here is going to be very important topic, and we are gonna do more hands-on today on each one of them and understand them from scratch. How you create a list, how you access a list, what different type of operations you can create on list, and how indexing and slicing works with list. And last but not the least, list comprehensions. So let's go first with the introduction. Now, lists, as we talked about or learned in last video of this series, if you haven't seen the series yet, please feel free to watch the last video, or you can skip it and just understand lists directly. So lists are the sequence types. They are one of the most versatile and used data structures in Python, and they allow you to store a collection of items which can be of different types, either numbers, strings, or even other lists. And as we discussed in our previous video, lists are mutable, which means you can modify them and manipulate them in different ways. There is a difference between Python lists and Python arrays. Arrays are generally in Python can contain only similar items, which means the items in array needs to be of same type. They can either be an array of numbers or an array of strings. They can't be a collection of different types. So that's one of the differences between list and array. As we go through this video today, we might discuss few more differences between lists and arrays at each point of time, as we discover what are the different operations which apply on list but not really on an array, or either way. So without any further delay, let's switch to our code editor, and I'm using PyCharm as usual, and let's start coding. Let's start with a new file. I have named it list.py, and I have also created a variable named called mylist, and I have assigned it 12465. So basically, when you create a list, it's done by enclosing a comma separated values within square brackets, right? That's a basic syntax of creating a list. Now, how do you access an element from a list? Generally, elements in a list are indexed starting at 0. So they are indexed at position 0. They are 0 based index list. So I can I can access individual elements of a list using a particular position using indexing. That's called indexing. We'll also dig deeper on this topic, indexing and slicing, in few minutes. But if you want to access, let's say, a particular position from a list, you can basically enclose that position within square brackets and try to access that. So let's try to print the 0th position in my list 1. So in my list, and which is 1. If I do the 0th position, ideally it should just print 1. So as you can see, it has printed 1 by accessing an element, right? So now how do you insert an element to a list? Okay, now I'll just comment this out so that we can move to the second one. So how do you insert an element to the list? There are two ways. Again, the way we accessed the element from a list was enclosing the position in a square bracket. Same way, we can use the enclosed position in a square bracket and assign it a value. So let's say I want to basically change the value at the 0th position, and I want to update this with, let's say, 10. Now if I print my list, I will find that the list now should become, which was originally 12465, now should become 102465. So that's what you can see in the console. It's printing that, right? So this actually overrode the element at the 0th position. It replaced 1 with 10. But if I just want to add an element at a particular position without removing any element from the list, I just want to extend the list by adding a new element. So let's say I'm adding 10 instead of replacing 10. So let's comment this out and we'll keep our list original, which is 1, 2, 4, 6, 5, and I just want to add 10 now at the 0th position without removing 1. For that, I can use insert method of Python, and I can say that okay, at the 0th position I want now 10, and when I print it, it will generally assign 10 at the 0th position and basically shuffle 1 and shuffle all the other elements to the left of it. So here you can see, sorry, to the right of it. So what you can see here is the new list became 10, 1, 2, 4, 6, 5. It didn't really replaced 1. It instead added 10 at the 0th position and moved other individual elements by 1 position towards right? So this is the main difference between insert by using insert method or insert at a specific position using the subscript. Correct. So let's comment this out as well, and we will only play around with our original list, which is 1, 2, 4, 6, 5. Now let's say I want to add an element to the end of the list. For that, append as a method is used. So I will say mylist.append and I'll add 10 to it. So when I print this again, I should have 10 at the end of the list. Now the new list will be 1, 2, 4, 6, 5 and 10 at the end of the list. So that is how you can append an element to the end of the list. I can remove an element from the list as well. So, but remove has a property. Remove method has a property that it will remove the first occurrence of the element in the list. So first let's try to just remove a particular element from the list. We'll keep 10 in the list as it is, and let's try to remove the same 10 from the list. So we'll say mylist.remove 10 and then print it back. It should ideally give me the original list which we had, 1, 2, 4, 5, 4, 6, 5. Now if I print it, you can see 10 has been removed from the end of the list, right? Now what if there were 2 5 in the list? There were 5 was occurring twice in the list. Now let's try to first append 5 at the end of the list, at the end of this new list, and let's have 5 with count 2. So here if I just print my list again, I'm gonna see 5 twice at the end of the list. Yes, that is what happened, right? Now if I do a remove, it will remove what position it will remove. It will remove the first position of that particular element. So when I just do mylist dot remove 5, so you will find, okay, maybe instead of adding 5 at the end of the list, let's try to do an element which is at a different position altogether and not consecutive. Let's try to add 4 at the end of the list instead of 5. Now let's try to print it again and we'll see 1, 2, 4, 6, 5, 4. So we have 4 at the end of the list. Now if I try to remove 4 now from the list, it's going to remove the first occurrence of 4 from the list, which is at the position, index position 3rd, right? So if I just run it again, so okay, we didn't print it. So let's print this. So if I just run it again, then the 4 is gone. 4 really is gone from the second index position of the list, right? Pop also does the removal of an element from the list, but it also returns that element. So let's say I'm removing 1 from the starting position. So I will say print mylist dot pop and give the index position which I want to remove. And then again, if I print that list, the 1 will be returned as part of the pop and will no longer be in the list. And that's what happened, as you can see in the last 2 lines, right? Now I can sort a list as well. So I can just simply do mylist dot sort, and if I do print on that list, now I will see that it has done an in place sort. So generally it will be should be becoming 2, 4, 5, 6. So that's what it became. Also I can reverse the sort. I can do a reverse sort. So I can do mylist dot reverse and then print mylist, and it should be 6, 5, 4, 2. That's what happened with reverse, right? The last method is how to find the length of the list, or the number of the elements within the list. That is pretty straightforward. There's a built-in function called length which applies to all sequence types. So I do length of my list, and it's gonna give the length as 4 because that's what has been left now in the list. So as you can see, it has printed 4. So these are the basic common list operations which we can use on a daily basis in our application, right? And even to for the data structure modification and manipulation. So these are the common list operations. Now in the next one, let's talk about indexing and slicing. Now let's talk about indexing and slicing. They are the most powerful features in Python that actually allow you to access and manipulate elements of lists. So if we master these two techniques, we can actually write very expressive and concise code and also use lists better, right? So indexing, which we discovered just few minutes back, was that it allows to access the individual elements of a list by their position. And in general, in Python, in lists or in any sequence type, the index starts from 0, meaning the first element of the list is at index 0 and the second element is at index 1 and so on, right? So assuming we want to print one of this list, one element 1 of this list, which is at position index position 0, so we will just do print my list as we did earlier as well and do 0th index position, and when I run this, it will actually print 1, right? So if I want to print the third element of this list, which is 4, which is at the second index position, so I will do my list and do 2, it is gonna print 4. So 1 and 4 got printed when I actually used a particular index and referred that in a subscript. So that is what is indexing, basically accessing an element, an individual element by their position in Python. Now I can also access elements with the negative indexes, right? What does that mean? That means that if I use negative indices, which is not there in any other language, but if in Python it does allow you to use negative indices. So I can basically use -1 or -2 and it will refer to the last element in the list, okay? So if I use the same list and do print my list and do -1, it's gonna print the 5 which is at the end of the list. So I'm gonna just print this and you see that I have 5. Now if I do -2, then it's gonna print the second last element of the list. So this way you can basically, if you're starting from the negative index which starts from 1, you can basically print the list in a reverse order. Now if you can see, it has actually printed 6 as the second last element of the list, right? So this is all about indexing. You can basically access an element by the beginning positions or by the positive indices which are for the start of the list, or by the negative indices which are at the end of the list, right? Now comes slicing. What is slicing? Slicing is actually allowing you to basically access a sublist from a list, basically access a portion of a list, and you can create a new list with those extracted elements as well, right? So let's first clear this console for us, and also let's remove this indexes, accessing indexes also, and let's focus only on slicing now. Now, as I told you, slicing will allow you to basically extract a portion of the list, and it has a start and it has a stop, as well as it has a step. So the format is generally start position, which is inclusive, and then I have a stop position, and then I have a step position, okay? So start is generally the inclusive and stop is generally exclusive. So basically, if I want to, let's say, if I want to basically start my list at the first index position, which is 2, and I will say I want to have till 6, then it is first index position, second index position, and third index position. I will have to give it 1:4, because if I don't give 4, 4 is exclusive, then which means it will just take it till 1 to 3 as an index position, right? So to include 6, I will have to give the index position as 4. So what we'll now do is print my list, and I'll say 1:4, correct? Now when I print this, it's gonna print 2, 4, 6. So let's try to print this, and it's printing 246, right? So pretty straightforward. That also, if I, let's say, don't specify anything as start, so the format, if the start stop step, if I just don't basically specify the start and I just do is to 4, it's gonna now print from the 0th index. Now let's use this, and I print it. Now you can see it actually printed 1246. And if I don't basically specify stop, and if I start from the same print, and now this time I actually do 1 is to nothing, now it is gonna print till 5. So let's try to print this. So now you can see it is printing from 2 till 5, 2465, correct? And by default step has a value of 1. So if you can see, it is going 1 position, it's skipping 1, it's basically going 1 position and then printing that, right? So it's adding 1 to this particular series which we are looking for, to this particular portion of the list which you are looking for, right? But I can say also that you step by 2, you don't step by 1, you step by 2. So basically, if I just say the same thing as I said previous, that I want to go till end of the list, so I'll keep that stop as empty, so this will go till end of the list. But I want to do skip by step by 2, so basically skip the second consecutive position. So here if you see, the last is 26, so basically it printed 2, which was the first index position, it skipped 4, and then it printed 6, so it skipped 4 and it printed 6, right? And then it skipped 5, so again there is nothing else further, so it just printed 2 and 6, right? So this is how the slicing generally works in the list. Okay, now I can also basically use the way we used indexing to assign a value as well. The way we access it, we also assigned a value by using indexing itself. Basically we referred an index position with subscript and assigned it a value, right? Same way we can modify the list with slicing. So let's say I want to change this whole 246, which means 1 is to 4, with some value. So I'll access that and I'll say my list 1 is to 4, and I want to give it a new list. I'll say it is now 5, 6 and 7. Now if I print my list, now if I go and print my list, it's gonna print basically 15675. So it replaced 246 with 567. So I can also use slicing to modify a list, not alone indexing. So this is how powerful indexing and slicing are. And if you master them, you can master anything on list. Cool. This is all about indexing and slicing. And now let's move to list comprehension. Let's start now with list comprehensions. Let's first clear the console from our previous output, and we will just focus on list comprehensions for now. Now, what basically is list comprehension? List comprehension is a way to create lists in a more concise and readable syntax. It's like a compact form of loop that allows you to generate lists quickly and efficiently. Now, how does the basic structure of list comprehension looks like? So basically what happens is, let's say I'm creating a list from, and I want to iterate through a different list and generate a new list. So what I will do is, here I will have let's say for item in any other iterable, right? And if I'm accessing that and trying to do anything on that as an expression, then I basically put that as an output of the new list. So here new list is a list that will be created. Expression is just the calculation on the particular item which we are accessing from that iterable. An item is the represents each element of that iterable. Can be a list, can be a range. An iterable is nothing but another iterable object, which can be a list, tuple, or a range, right, which we want to loop through. So as you can see, the syntax is pretty straightforward. I am able to create a new list with the subscripts, and just instead of enclosing elements as comma separated list, I'm just doing a for loop within a subscript and accessing the value of an iterable from which I want to create a new list. So pretty straightforward, right? So let's assume that you want to basically find the square of each number which are there in a list. So let's say you have a list called numbers. I'm gonna clean up the older list. Let's say you have a list called numbers, and they are nothing but like 1 2 3 4 5. I renamed the previous one just to make it more readable. So now I have a list called numbers 1 2 3 4 5, and I actually want to basically skewer each number of this list and generate a new list. So basically, if I have to do that, if I was doing, let's say, for loop, what will I would have done? I would have actually created first an empty list. Let's say I would have created skewered numbers, a general basic for loop, right? I would have done that, and then I would have iterated each element in that list and would have actually done scared numbers. And what do you do to add an element to the list? Append. So you use append, and then you generally do x. And how do you do a power raised to power exponentiation in Python? Use double star, and then 2. And I would have actually gotten a scared numbers of each number in that list in a new list called scared numbers. So I would have now if I print the scared numbers, then this is gonna give me basically the square of each number in that list. So as you can see, it is giving 1 4 9 16 25. But see how many lines of code I have to write, correct? Now I will try to do the same thing with list comprehension, right? So if I do the same thing list comprehension, it becomes just one line of code. So scared numbers, and what am I doing as an expression? I am actually doing x raised to power 2, and for every x which I found in numbers. Straightforward, right? It actually just took me one line of code to do that iteration and generate a new list. And if I print this again, then it is going to give me the same list which I just generated by doing a basic for looping. Correct? So these were like 3 lines of code, whereas this just finished in 1 line of code. This is that powerful if we want to do list comprehension, right? It's a very powerful tool which is allowing us to create list based on existing list or other iterables. So it's a very handy technique for streamlining our code and making it more expressive and concise and elegant instead of writing too many lines of code just to create a new list, right? So this is all about today's session, and I hope we learned together. And if you like this video, please feel free to subscribe. Otherwise, you can just browse along and learn whatever we are doing here. Thank you so much. I hope you come back for the other video of the series.